Hello, class. Okay, so today what we're going to be doing is we're going to be continuing our study of parallelograms. And we're going to put what we've learned, the properties that we've been learning about, to good use, and we're going to do a proof. And what we're going to be proving is ABCD is a parallelogram if and only if its diagonals bisect each other. So we notice two things. We see the word bisect, that means to cut in half. We've seen that before. And we also see the if and only if. That's big. If and only if. We've learned about this before. When we're doing proofs, or logically, what that means is that if it's a parallelogram, then its diagonals bisect each other. And it means if its diagonals bisect each other, then it's a parallelogram. So we have to prove both directions, both of those things. So we're going to start our proof, and we know that this is just scratch work. We're not actually writing down our final proof. That's too stressful. We're going to start by figuring out what we know and see how we can pull that together to prove what we want. So first, let's figure out what we do have. What are we given right away? We know that ABCD is a parallelogram. What that means is that our opposite sides have to be parallel. So AB is parallel to DC, and AD is parallel to BC. We have that, and that can get us some other stuff. There's other stuff that we can figure out from those facts alone. So let's look at it. We can see that the diagonals that we're trying to prove stuff about are actually transversals between these parallel lines. See that? And so we have some facts about transversals and parallel lines. We've learned about those before. We know that alternate interior angles, so BAC and DCA, must be congruent. We also know that ABD and CDB are also congruent because they're another set of alternate interior angles. We also know by our previous results that opposite sides are congruent. So we know that AB is congruent to DC and BC is congruent to AD. So now we've learned a lot, we've figured out a lot of things that we know, but how can we use this? That's our big trick. So, well, what we really need to show that AE is congruent to EC and DE is congruent to EB, so that they exactly cut each other in half. That's what we're trying to show. So now, how can we do that? We have to show congruence. So what tools do we have in our toolbox that we could maybe use? Well, we can't measure because this is a proof. We have to show it for all cases, so measuring would only really show it for one, and only sort of precisely, not perfectly. And similarity won't work because those only show that two sides are proportional but not exactly equal. What do we have to show exactly equal? Well, we do know a lot about congruent triangles, and we know that corresponding parts of congruent triangles are congruent. So maybe that could work because we've learned a lot about those. That was a big topic. So let's see how we can use those. First of all, we need to figure out which triangles we want to show are congruent. Because we can't just show any triangles are congruent. We have to show specific ones. So let's look. If we show that triangle ABE is congruent to triangle CDE, that implies that AE is congruent to EC by the congruent parts of congruent triangles being congruent. The same with BE and DE. So we now know that we want to show that these two triangles are congruent. Let's see if we have enough. What we know is that these angles are congruent and these angles are congruent, and we know that this side is congruent. So we've got two angles and a side. We've got some congruence theorems about that. Let's see if they're in the right order. What congruence theorem would work? Maybe angle side angle? Yes, angle side angle works. We can do it. And so we did it. We showed that these two triangles were congruent, which means that the diagonals bisect each other, which is exactly what we wanted. Awesome. Perfect. But shoot, wait. There was one, that was just part one. We still have to prove part two. So we can do this. We were doing well in the first one. We can do this again. So what do we want to show now? We want to know if we want to show that if the diagonals bisect each other, then it's a parallelogram. So we know that the diagonals bisect each other. What else does that tell us? That means that AE is congruent to EC and BE is congruent to ED. So we know that. What else can we figure out? Well, since these angles are vertical angles, we know those have to be congruent. We also know that these are vertical angles. So we've got two sides and an angle. Let's see if that's enough. Well, we could try congruent triangles again. We've got two sides and an angle. That could give us something. It does. It shows that this triangle is congruent to this triangle by side angle side, and this triangle is congruent to this triangle by side angle side. So now we know that these sides are congruent and these sides are congruent. We also know that these angles are congruent. I'm going to get out, sorry about that. I'm going to get out my pencil. We know that these angles are congruent, and we know that these angles here are congruent by congruent triangles. So that helps us a lot. I have that written down there. But does this help us? Yes, it does. Because by I-29, one of Euclid's postulates, we know that since alternate interior angles are congruent, opposite sides are parallel. And now we actually did it. We are done. So your job now is to take the scratch work that we did. Hopefully you're taking notes. If not, go back and take notes again. It'll be good to watch it twice. And what I want you to do is, once you've taken your scratch notes, rewrite it up nicely. So we've done our scratch work. You have all the pieces, but write it up nicely. You can use all the symbols you want. We can make it really small. It could actually be written in about this big if you wrote it really small and used all the symbols. And then on the next slide, you're going to switch, and there'll be a matching game where you'll match the simplified pieces, so your final proof pieces together to get the order, to make sure that we were following this. So once you've done that, you'll come to class ready to keep learning. Awesome. See you tomorrow, class. Have a good night.